How does a computer actually think? Imagine if I handed you a rock, not a smart device, not a calculator, just an ordinary piece of silicon taken from the ground. Now imagine that after years of engineering, that same material could play music, render movies, launch rockets, diagnose diseases, and even hold a conversation with you. How is that possible? How can something with no intelligence become one of humanity's greatest inventions? To answer that question, we have to begin somewhere unexpected. Electricity. Electricity doesn't understand mathematics. It doesn't understand language. It doesn't know what a photograph is. It only knows one thing: move. Every computer on Earth, from the smallest smartwatch to the largest supercomputer, is ultimately controlling the movement of billions of tiny electrical charges. That's it. Everything else is built on top of that. But controlling electricity is difficult. If electrons could flow anywhere they wanted, computers would be impossible. So engineers invented something revolutionary: the transistor. Think of a transistor as an incredibly tiny electronic switch. It can either allow electricity to pass or block it completely. Only two possibilities: on or off, 1 or 0. These become the first language of computers. Binary. At first, one switch isn't very useful, but connect several together and something incredible happens. You can build logic. Imagine two light switches controlling one lamp. The lamp only turns on if both switches are on. That simple rule is called an AND gate. Another rule might turn the lamp on if either switch is on. That's an OR gate. Another might flip the answer entirely. That's a NOT gate. Individually, they seem trivial. Together, they become the building blocks of reasoning. By combining millions, then billions, of these tiny logical decisions, computers learn how to add numbers, then subtract, then multiply, then compare. Eventually, they can make decisions, not intelligent decisions, logical ones. Now imagine billions of transistors switching on and off every second. Modern processors perform this dance billions of times each second. Every website, every video game, every movie, every scientific simulation, every artificial intelligence model. All emerge from countless microscopic switches changing state faster than your eyes could ever perceive. But a computer still has another problem: it forgets everything. The moment power disappears, those electrical patterns vanish. So engineers created memory. Memory stores these patterns so they can be read again later. Some memory is incredibly fast but temporary. Other memory is slower but permanent. Together, they allow computers to remember instructions, images, music, and entire operating systems. Now something magical happens. The processor begins reading instructions from memory, one after another: fetch, decode, execute, repeat, billions of times. This endless cycle is the heartbeat of every computer ever made. When you click an icon, you're not opening magic. You're simply asking the processor to execute another sequence of instructions. When you type on your keyboard, you're changing electrical signals. When you watch a movie, you're seeing millions of calculations transformed into pixels 60 times every second. Even artificial intelligence follows this same rule. Despite sounding mysterious, AI isn't powered by magic. Deep inside the hardware, billions of transistors are still switching between zeros and ones. The difference is that those switches now perform mathematical operations learned from enormous amounts of data, whether it's recognizing a face, translating languages, or generating text. Everything ultimately becomes mathematics, and mathematics becomes binary, and binary becomes electricity. The next time you hold your phone, remember this: you're holding billions of microscopic switches, each smaller than a virus, working together in perfect synchronization. None of them know what a photograph is, none understand music, none know what the internet is. Yet together, they create the digital world we now live in. Perhaps the most fascinating part isn't that computers can think, it's that they never actually do. They simply follow the laws of physics with extraordinary precision, and somehow, from nothing more than controlled electricity, emerges everything.